Hi everyone. Today we're going to go over section 3.1. Essentially it's just a review of exponents. So if you want to title this one 3.1 Review of Exponents. It's the same rules that we used in Algebra 2. Okay, we're just going to review them. So as we go through here, I'll make little notes off to the side to get us started with all these properties. So the first one we have is the product of powers property. And you'll notice that your exponents, again, this is review of exponents, so we're focused on the exponents as we go through these properties. Here on the first one, whenever we are multiplying, as long as the bases match, we call these bases down below, as long as those match, we are going to take those exponents and add them. So I'm going to just make a note off to the side that whenever I'm multiplying terms, I'm going to add the exponents. And then when I have a power of a power, so I have a power raised to another power, I'm going to multiply those exponents. Moving down the list, power of a product. So if I have this m out in the exponent, I need to put that m on both terms. Okay, that's what we tend to forget. So I'm going to write here distribute exponent to all pieces. So even if we had a number instead of just variables, that number is also going to get that exponent of m as well. So we'll have some of these problems here in a second, and we'll discuss that. Then we have the quotient of powers. So you'll notice if you're dividing, you will take the exponents and you will subtract them. Again, all of this is only if they have the same bases. Okay, notice how every single one has a's. Okay, then power of a power, very similar to the one up above. That m is going to get distributed to all pieces again. So if you want to write that in, you can. It's the same property. Distribute exponent to all pieces, top and bottom. Then we have the negative exponent. This is the one that's going to come more often. So we're going to have to know how to rewrite a negative exponent. We can never have negative exponents. So in order to write it as a positive exponent, it has to be flipped to the denominator. So, and vice versa. So if it was ever in the denominator, like here, it's going to be moved to the numerator, which will be a over a to the n power over 1, which is just a to the n. So it's going to flip back and forth. And we'll get lots and lots of practice with these negative exponents. Moving down the list here, we have the zero property, which means anything to the zero power is always going to be 1. Doesn't matter what that is. Wow. Okay, let's write this correctly for you guys. It says always. So always keep that in mind. And then last but not least, we have this rule here, and I kind of want to call it the radical rule. Okay, I don't know if that's really the special name for it or not, but it makes sense because when you have a fraction in the exponent, that fraction is going to go into a radical. So the biggest thing to pay attention to here is the bottom number, that denominator of your fraction, is going to be the type of root you're looking for. And then the top number is going to be the exponent on the inside of the root. So if I had, for example, b to the 1 over 2, b to the 1/2, the 2 is going to become the root portion of my radical, and then b is going to be raised to the first power. So the numerator is going to go with the exponent inside the root, and then the denominator is going to be the root that you are actually going to. So this would be called the square root of b. Anything with a half power is a square root. Okay. And then we have just some key things here. Multiply whole numbers together, multiply radicals together. Fractions move negatives first. These are just rules that we're going to do to simplify exponents as we go through. So these would be ranked top to bottom here is probably what I would have to say. Go ahead and read through those. And then we're just going to do some examples. I have my teacher key posted in Teams under the Files tab. This one's going to be for Unit 3, so if you want to check your answer as we go through and look at the Files tab, you most certainly can. Okay, so we're going to get started. The directions are the same throughout all of this. So we're just simplifying expressions using those properties up above that we just covered. So the first one, simplify each expression. Okay, here on this example, you're going to notice that the fraction or the exponent is a fraction. So if you want to use your property, we're going to go up to the one that talks about the exponent of fractions, which is that radical one right there. Okay, so we're going to rewrite this as a nice radical term. So we have a 3 that's going to go into my root, and then -8 is still the base, so that's going to go inside, and it's going to be raised to the first power. So it's asking, what is the cube root of -8? So this cube here is looking for groups of 3. So if I were to take -8, I know that it's 4 times 2, and I can simplify 4 into 2 times 2. Well, I'm looking for groups of 3 of the same number. So if I look closely, I see that I have one group of 2. So the 1 is going to be the exponent when I rewrite it, and of the number 2. So the cubed root of 8 is 2, but more importantly, the cube root of a -8 is going to be a -2 to the first power. So this one we can simplify. As we go through with variables, we won't be able to simplify as much, but we will try. Okay. Going into the next one, again, fraction as my exponent. We're focused on the exponents here in 3.1. So we're going to have the 4th root this time of 16 to the 3rd power. Okay. Now, I would recommend using a calculator for this one. And that being said, 16 to the 3rd power is going to be 4,096. So here we're looking for groups of not 3 this time, but groups of 4. So when I split 4,096, I'm going to look for the same number 4 times. And if I look closely, I know that, or I can use a calculator, I know that 64 times 64 will give me 4,096. Again, you can check that. And then I can break 64 into 8 and 8, and again into 8 and 8. Now, I might have chosen 64 and 64. You might have chosen other numbers like 2 and 2,058, and then broke down 2,058 from there. It doesn't matter. You'll still end up with the same exact values, or you should end up with the same exact values. So I'm looking for 4 of the same number, so I'm going to stop here because I see 4 8s. So I know that the answer here is going to be 8. Okay, again, I used a calculator. You can use a calculator as well if you would like to. Question 3 is looking for groups of 3. That 3 is part of my radical, so it tells me how many I need in a group. And so if I write this out, for every term, I have 9 A's. A. There's 9, and then I have 11 B's. And you'll notice that I'm leaving a space every 3rd B, or every 3rd letter. And I'm doing that for a reason, and you'll see why here in a second. So then I'll put that root way back over there, and I'll put a 3. So when I go through these, I know that I have one group of 3, one group of 3 A's, another group of 3 A's, and a 3rd group of 3 A's. So I can take out 3 groups of A, and I have no leftovers. Then I'm going to move on to B's. I have 1 group of B's, 2 groups of B's, 3 groups of B's. I can take out, again, don't use the highlighter function there. I can take out 3 groups of B. And then last but not least, I have 1 group of C's that I can take out. So that's going to be an exponent of 1. And then whatever I wasn't able to highlight, that's going to go back into my cubed root. So I have 2 B's left over, and then I have 1 C also left over. And that will be my final answer. So we're just simplifying expressions here, simplifying those exponents and what have you. But then we're going to get into practicing converting and getting it down into the real terms of exponents. Okay. So I'm going to skip down here to question 4. Okay. And we want to do this certain kind of in like an order process. So before we get started, it depends on our numbers. Okay, so sometimes you might see these negative exponents inside those parentheses and want to flip them. Okay, you can totally do that. Or we can work on that power of a power first and distribute that -1/3 to all of my pieces, and then we'll go in and worry about those negative exponents in just a moment. Okay, but it's good that we're acknowledging that we do have negative exponents and they're going to play a role here shortly. Okay, so what I would do first is I would take care of this -1/3. So I'm going to distribute that -1/3. This is the power of a power rule. And I have to remember I'm going to distribute it to every piece. That's most important. Okay, so while I do that, I'm going to have x to the +3. When I distribute -1/3 times -9, it's going to give me a +3. And then when I move into the denominator, I also have to take this -1/3 power, and it's also got to go to that 81. So just because there's a number there, we can't forget about it. So it's -1/3 on my 81. And then I go and I move to my y. So -1/3 times 6 is going to give me a -2. And then for my z, I'm going to have -1/3 times -12, which is a +4. Okay. Now with that simplified, I just took care of my power of a power. Now I can focus on my negative exponent rule. So I'll let you know what rules I'm using as I move along here. So the negative exponent, if I ever see a negative, that means I have to flip it to the other side of that fraction to get it to be a positive. So what that means is my 81 to the -1/3 is going to move to the top, and it's going to become a positive exponent when I move it to the top. Same thing with your y. It's going to become y to the +2. And everything else, since it was already positive and didn't have a negative exponent, is going to stay where it was. So the x cubed is going to stay, and the z to the 4th will also stay. Okay. So we're still cleaning up shop. We don't like to have fractions as our exponents, so we're going to use that radical rule. And we're only going to use that piece on this 81 here, because that's the only one with a fraction as the exponent. So I'm looking for the cubed root of 81 to the 1st power. I'm going to close off that root there. Still have a y squared, still have an x cubed, and it's all over z to the 4th. So to finally simplify, I'm looking for the cubed root of 81. Okay. You can use a calculator if you'd like to, or we're looking for groups of 3 here. So if I take 81 and I split it off into 9 and 9, split 9 into 3 and 3, you're doing it into its prime values. I'm looking for groups of 3. So I have one group of 3 of the same numbers, and then I have one left over. So that means I can take out one group of 3s with a 3 left over, but remember what type of root it was. It was a cube root, so we have to remember that cubed on my root again. And once I'm done with that, I'm just going to bring down the y squared, the x cubed, and the z to the 4th. Okay, I'm kind of flying through this kind of quickly, so take a minute, look back. Does it make sense? We're doing one step at a time. The first step was power of a power. Okay, power of a power, then I took care of negative exponents, and then the radical, and then I just simplified the radical from there. Okay, now this isn't the absolute positively order. You have to do it. All right, I like to go in this order just to kind of make it cleaner, not have to worry about that exponent of -1/3. I'm not a big fan of fractions, so if I can get rid of them sooner, that's what I kind of tend to do. But most definitely, if you wanted to go back to this problem here and stop here and say, oh, well, let's change that to a radical, because you see it's a fraction, you most certainly can do that, okay? But you have to know that your final answer, just as a rule of thumb, your final answer cannot have, come on, there we go, cannot have a negative exponent. So if you have your final answer written out on your homework, on your quizzes, on your tests, whatever it ends up being, your final, whatever it is, your final answer cannot have a negative exponent. If it has a negative exponent, it will be marked wrong, okay? That means that you didn't take care of the negative exponent rule. There is such a thing as a negative exponent rule, so we have to make sure that we are applying it as such, okay? For question number 5, okay, if you look through and you identify what's happening between these two terms, we know that we are multiplying. They're technically attached to one another, so we are actually multiplying them. And this was back in Algebra 2, and the way I like to explain it is you match the pieces. So if you have numbers inside, you're going to go to the inside of your root, and you're going to keep them inside, and you're just going to multiply like it tells you, okay? And then I also had variables inside, so I'm going to do the same thing. I'm going to multiply by the variables on the inside. If they were inside to begin with, keep them inside in your work until you know that you can take them out, okay? So as we simplify here, 3 times 12 will give me 36, and then x to the 4th and x to the 3rd, we know that we have to add these exponents because we are multiplying the main terms. So it's going to be 36x to the 7th. Okay. Now that I have this, I can simplify. Well, 36 is the same as 6 times 6, which I know that there is a little squared that lives in that root. If you guys were to say that out loud to me without knowing there was a 2 there, you would tell me that that is the square root of 36x to the 7th. So that means that there's a little 2 in here, signaling that I need to look for groups of 2 of the same thing. And then I have 7 x's. So I'm going to group them up in pairs so that it can help me when I go to pull things out. So I have one group of 6 that I can take out. And then I have 1, 2, 3 groups of x's. So the 3 will be my new exponent. And then my leftovers go back into my square root. Okay, so I will accept this, and then if you want to just put that 2 back in there, that's probably a good idea, so you get in that habit as well. Okay, otherwise we will assume that it's a square root. So my final answer is 6x cubed square root of x. Again, if you want to check these answers as you see them and just check them on your teacher notes posted on Teams, you most certainly can. Okay. Moving on to question 6. This looks like a lot when I first look at the problem, so I am going to take it one step at a time. All right. And more importantly, before I get to any of this in the numerator, all right, you'll notice that you have this fraction here. That fraction tells me that there's going to be a radical. Well, I have a radical in the numerator, so let's see if we can get that denominator to be very similar. So I am going to use my radical rule. So I'm going to keep the numerator exactly as I see it. The cube root of 108, a to the 15th, b to the 10th, divided by, and then the cube root, or excuse me, the 1/3 is applying to both pieces. So I'm going to do the cube root, because it's a fraction, of 2b. Now the reason I did that first is because now you'll notice that the cube roots, or excuse me, the roots are the exact same. They're both cubes. So I can actually combine this as one entire cube root. And I'm doing this for a reason. Because when I have it all as one entire fraction now inside that cube root, I can simplify this fraction to make it look a lot nicer. So when I do that, I still have a cube root, but when I simplify the denominator and the numerator, 108 divided by 2 is going to give me 54. I still have an a to the 15th, but when I get to my b, I have b to the 10th divided by b to the 9th, so I am going to use the quotient rule. And the quotient rule tells me that I take my exponents and I'm going to subtract. It's always the top minus the bottom. So 10 minus 1 is going to give me b to the 9th. And they're positive, so they get to stay in the numerator. And now I just have the cube root of 54, a to the 15th, b to the 9th. So I'm going to simplify. Okay. A to the 15th and b to the 9th is actually pretty easy. So I'm just going to focus on 54. Because that one's not so easy for me. So I'm going to say 9 times 6, 3 times 3, and 3 times 2. So what I can take out in terms of 54 is I can take out one group of 3 with a 2 left over. So one group of 3, and I'm going to leave that 2 for just a second. I have 15 A's. Well, if I take 3 groups out of 15, if I take out groups of 3 from 15, I will have 5 groups in total that I can take out. And then if I have 9 total B's and I get to take out groups of 3 at a time, I get to take out 3 groups of B's. There's no leftovers on my A's any longer. There's no leftovers on my B any longer, but I still have that cube root of 2 from my 54 that I still have. Okay, make sure you bring back that cube root as part of your final answer. And that is answer number 6. Okay. Now we're going to look at some like terms here. So we still have square roots. And more importantly, we are subtracting these from each other. So we have square root of 5x minus 7 square root of 5x. The important detail here is that the square roots match. So you'll notice, and sometimes it's a little bit difficult to see, it's very similar as if I were to write 1x minus 7x. The only difference is now we're talking about these square roots of 5x's. Okay, but it's still similar. They're still like terms with one another. They just have square roots with them. So what I'm going to do is I'm going to identify that there is indeed a 1 in front of that square root. So I'm going to say, well, what is 1 minus 7? That's a negative 6. And since they're like terms, I'm going to keep the square root of 5x. And believe it or not, that is the answer. Okay, as long as the terms inside match, you can combine them as if they were like terms, because they are like terms. Okay, moving into question 8, though, if you look closely, you have a root 27 and a root 12. Okay, now you can't just stop and say, oh, there's no answer. All right, there's a hint that these are going to break down in some way to give you the same root in the end. So I'm going to break these down first. So 27 can be 9 and 3, 3 and 3 for 9. And then 12 can be broken into 4 and 3, and then 2 and 2. So now I'm thinking, well, what kind of roots are these? These are square roots. You don't see a little square in that corner, so we assume that it is a square root. Otherwise, it would say a specific number. So if it's a square root, we're looking for groups of 2. So I have one group of 3, and I have one group of 2. But I have to keep them in order. So the group of 3 I get to pull out here, and I go back because I have a leftover. So this 3 here will be the leftover still remaining. For the second piece, I was able to take out one group of 2, and again I had a 3 left over. So this 3 gets to come out, or excuse me, gets to stay in. All right, but I can't forget about this original 5. That original 5 has to come back, and we're going to multiply. So whatever you end up taking out, you have to multiply with whatever coefficient was there to begin with. So 5 times 3 gives me a 15 cube root of, 15 square root of 3. And then I'm going to keep adding 2 square root of 3 as well. Now these match. So I'm going to say matching roots, which is good news for us because now I can do exactly what they're telling me to do. I can add these two terms together. So I have 15 root 3 plus 2 root 3. They're like terms. They both have the same root. So that's going to combine to give me 17 root 3 as my final answer. Okay. Again, if you look through the teacher notes, I go into these a little bit more explicitly on my comments off to the side, so that might be more helpful too. If you still have questions, by all means, just send me an email and I can help you out. Okay. Question 9. As we look at question 9, the same rules are going to apply like you're used to. So you see these two sets of parentheses next to each other, so we want to FOIL. If you don't know FOIL and you know it as double distribute, that's the same kind of idea. So I'm going to take this 2, multiply it out here to 5. 2 times 5 is 10. Take the 2, multiply it by the second term. That gives me a negative 2 root 2. So if you're multiplying just a constant, it's going to stay on the outside of that root. And we will continue. Square root of 8 times 5 is going to give me a positive 5 square root of 8. And the square root of 8 times the negative square root of 2, again, you're matching your pieces. If you're both inside, it's going to stay inside. So what's 8 times 2 on the inside? That gives me a 16. And of course, a positive times a negative will give me a negative. Okay. Well, right now I have a lot of terms, but nothing matches. But I have rules for square roots. Okay. Look at your 2 here. Can you simplify anything there? No. Okay, so that's kind of a hint that maybe all of your terms have to be square root of 2's. Okay, if you can't simplify one, it's kind of a hint that the rest might have to be that same square root. So let's test that theory. 8's going to break into 4 and 2, 2 and 2, and then 16 is going to break into 4 and 4. Again, these are square roots, so if you see pairs, you can stop. But of course, you know that 4 can break into 2 and 2's. So we'll leave it like that for now. All right. I'm going to simplify these before I continue. So I'm going to just bring down the 10, bring down the minus 2 square root of 2. I'm going to keep the 5 for now, and I'm going to combine my groups here. So this is a square root of 8, so I'm looking for groups of 2. So I can take out one group of 2 with a square root of 2 left over. This 2 right here goes back in to my square root. Okay. And then for the second part, I have one group of 2's for my 16, and I have a second group of 2's. So I'm going to keep the minus, and I have 2 groups of 2. So that 2 groups is going to be my exponent of the number 2. Let's go ahead and simplify really quick. Again, we're multiplying that 5 and 2. So I have a 10 minus 2 square root of 2 plus 5 times 2 gives me 10 square root of 2, and 2 squared gives me 4. Now I can combine my like terms. This looks a lot nicer. So I have 10 and I have minus 4. Those are like terms. They're both constants, so I can combine those. And that gives me a 6. And then I can also combine negative 2 root 2 and a plus 10 root 2 because they're like terms. They both have the same square root of 2 now, so I can combine them. Negative 2 root 2 plus 10 root 2 is going to give me a plus 8 root 2. Okay, this isn't the prettiest of answers, but it is the most simplified answer I can provide. Of course, you can go into your calculator and get a real decimal. That's not what we're looking for here. Okay, you're just looking for the simplified version of foiling that problem. All right. And then the last one here is question 10. So question 10, we see a lot. We see 32 up top. We see a 16 down below. So we can take care of that. All right. And then we see both x's. So we have x to the 5 over 3 and x to the 3 over 4. We'll take care of that momentarily. So I would always tell you to work out the main numbers, the coefficients, if you will. So if I take 32 and I divide it by 16, that's going to give me a 2. But more importantly, that's going to give me a 2 in the numerator. So then I'm just going to copy my x's with their exponents where they were already. So the only thing that changed now is I just did 32 divided by 16 and got 2. And now I have x to the 5/3 and x to the 3 over 4. But more importantly, they are being divided. So from here, I'm going to use my quotient rule. And my quotient rule tells me that when I'm dividing, I need to subtract my exponents. So I'm going to have 2x to the 5 over 3 minus 3 over 4. I'm focused on just the exponents, and I'm going to subtract them in one main term here. Okay, but we can't, of course, subtract without having the same common denominator. So I know that I have a common denominator between 3 and 4. That common denominator is 12. Well, looking back at the 3, what did I do to 3 to get to 12? I multiplied by 4, so I need to do the same thing to the numerator. Looking at the 4, what did I do to 4 to get to 12? I multiplied by 3, so I need to do that to the numerator as well. And if I rewrite this, I have 2x to the 20 over 12 minus 9 over 12. And then I can simplify. That gives me 2x to the 20 minus 9 gives me 11 over 12. Okay. We don't like fractions as our exponents because we have a rule that takes care of fractions as exponents. So I'm going to just finalize this with my radical rule and write my answer as the 2 out front because the the exponent only applies to x here. So it doesn't apply to the 2, so I'm going to keep the 2 out. And then I'm going to take the 12th root of x to the 11th power. And that, my friends, will be your final answer here. Okay. The notes, this isn't the end of them. There is one more section just for added practice. It's about 8 more problems. Okay, it's a little bit more in depth. Those will also get posted with our notes here, and those are just going to be added problems for you to try on your own. Again, those are posted in your team's files tab. All right. It is with the 3.1 notes. It's all the way at the bottom, those 8 more problems. So go ahead and check those 8 problems and see how you did. All of my work is shown. So if you have questions still, please, by all means, ask. Get some clarification. We're using those rules. If you need to add, remember you're multiplying terms when you add your exponents. When you subtract, we're dividing our terms when we're subtracting our exponents. All of those rules come from this very front page. So if you want to print this page out, you want to keep it in your binder, it will help us as we continue on in section or unit 3, this chapter. All right, so give them a shot, give those 8 problems a shot, and then